But because information isn't always tabular in the way that it's best arranged, data doesn't necessarily work that efficiently this way. This relational databases work really well when you have more tabular type information. But when you start to encode information that has lots of relationships, which are, I think when you're looking at information that's about people and about social activities, it's really hard to encode it in a very kind of straightforward tabular fashion. So there's this other way of encoding information which they refer to as object-oriented. This idea that you can have many-to-many relationships between, I guess, clusters of data. Yeah, it's a very difficult thing to explain, but this is an example of being able to bring two pieces of information together which has data and using it to produce a third piece of information. And if you tried to squash that information into a tabular format, you might actually destroy some of the meaning in the data that you're keeping. So this is the image that I have for this idea that actually it's kind of like trying to force it into a square box. Information that's round, trying to force it into a square box. It doesn't work very well. So we're moving on to this idea of a graph, which really blew my mind because I'm used to tabular format, and then I kind of grew up a bit and moved into what's called object-oriented databases. And then Connell started talking about RDF, and I thought, what the hell is RDF? And for me, it's kind of like, when I showed you that first slide that says the eye colour is blue, it's actually taking the smallest piece of information and keeping that. It's not a complex table of 15 columns and 40 rows. It's actually taking the smallest piece of information, which is subject, object, and predicate. This idea of a thing, something about the thing, and the something between them. And it really challenged me. It challenged me to understand about atomizing data, that you weren't kind of ordering it into a table or clustering it in an object-oriented database. You were actually just keeping the little atoms that were meaningful. And when you stack those atoms up next to each other, some of those atoms cross over each other because they say the same thing. And I'll get to that hopefully to make a bit more sense. Linked data is when you actually agree, like if Deb and Con can agree that I am Ingrid, they both point to me, then I can turn into something that you can reference. So this idea that you can, two independent entities can point to a third entity and say, we both agree that that is the same thing. So that's what I call linked data, in the sense that you have agreements about what something is. So there's some principles around linked data that Tim Berners-Lee and those who are interested in making data available as linked data has put out. And so trying to make, I guess, it possible to describe entities like me on the internet, you need a URI. You need to be able to point to me on the internet. And you need to have a protocol that you can get to me through that. And you need to provide useful information about me, like my name, and maybe include links to other URIs so that other people can actually find me. And there's this idea of the linked open data cloud that you can actually say, I've got a whole lot of information about a subject that I'm interested in. I've encoded it, and here I am, I'm pushing it out there. So Deb and Con have data about me, they've pushed it out into the cloud, then all of a sudden they discover that all of you have information about me. So all of a sudden I'm the node in the middle and you're all pointing at me like that. So it makes it possible for someone who wants to find out about me to come through your data and to me, then find your information about me and your information about me. So all of a sudden it's like a series of nodes pointing into the middle. And that's a very blurry picture of the linked open data cloud. The green stuff on the right, I will say, has come from the library community. And there's other domains that have published their data about entities, things, people, subjects, into here, so you can point to it and reference it. So linked data has a URI, it has the ability to get to it on the internet, and ideally is a permanent URI, so you know, I might die, but my link on the internet might still exist, so we don't have broken link problems, and you can continue referencing me. So I went through a process of trying to give you an example, and I've used Deb as my example. Does she exist on the internet? Does Deb Verhoeven exist on the internet? So I went through and had a look at Trove to see if I could find an ID for her from the National Library, and sure enough I did. And I also found a reference to her from RMIT, and she told me that she has a VFID and a Library of Congress authority file ID, but you'll notice at the bottom those are just IDs, they're not resolvable, and you can't get to them on the internet. Whereas the one at the top is resolvable, and you can get to it on the internet, so when Deb pops her clogs, she'll still be referenceable on the internet. We'll all be able to point to her if we've got something about her on the internet. So what is RDF? I guess I've described it as, it's like, for me it's like a really skinny container with 3 pieces of data in it. So it's a really, really long container with these 3 pieces of data. Subject, object, predicate, the thing that links those two. And there's thousands of them. Because if you want to, I guess, provide data about something that's really rich, you're going to have thousands of them. Hundreds, millions, trillions, goodness knows how many we're going to have in honey. But they're called triples because of those 3 components. Subject, object, predicate. And the way that we capture it when we're actually building it is we use this markup language called XML. So Con showed you a representation of a person in XML using this encoding scheme, AAC CPF, or RDF is just another language, if you like, which is reflected in that markup language. So there's a bit of RDF in XML, and I wonder who that might be. And it's actually readable, it's human readable in the sense that you know that that is actually a description of Julia Gillard, and it's come from Wikipedia. But you can see in there's some slightly different information under the top bit, which has this thing called title and publisher. And the little DC before that is a code for a schema that's called Dublin Core. So it means that they're reusing the way that people can capture information in the library and I guess other domains that's common. So everybody who knows that it's been encoded that way will know what to do with that data because the Dublin Core is referenced up the top, I think. Yep, DC. So it's actually got information in there. It's just really hard to see, and it's designed for computers, which is why it's so jolly hard to see. And why it's so much nicer looking at the data behind the Encyclopedia of Australian Science through its presentation format, because that's actually much more palatable to the human eye. So RDF is an exchange syntax in the sense that you can actually exchange data with it. And it has a grammar. And so I've got an example of this idea of logic. Ingrid is a fool and Connell is a fool. Ingrid and Connell are both fools. You're making an assertion because we both share the same subject or object. So you can actually link us by the fact that we're both referred to as fools. So then it makes you think, what is a fool? Okay, that's something that people might disagree about. So when we do the Honey project, we need to be sure that we can either allow people to say, yes, I mean the same word that you mean when you call someone a fool, or actually, no, I think Connell's a bit smarter than that, so I don't think he's a fool at all. Ingrid is a Kiwi and Connell is a Kiwi. Ingrid and Connell are both Kiwis, and he will say history pin like I do. But what is a Kiwi? And so that could be a person born in New Zealand, or a citizen, or it could be a bird. So if we define what a Kiwi is, then we can see if Connell and I actually have something in common. So we could link these statements about Con and I. So I decided to graph that for you in the best way that I could to have an understanding. So I started this idea of having a look at a graph. And so there it is, there's the graph. And if we define a Kiwi as a person either born in New Zealand or who is a citizen of New Zealand, this idea of a Kiwi, this idea, this thing, and we define it as it has these properties, then we can say, yes, Colin and I are both Kiwis. And that can be encoded in RDF. And we can put that up on the internet so everybody knows that we were born in New Zealand. I know it's riveting stuff, but it does mean if you want to share your data with someone who's working in a space near you and you know that you've both been over the same territory, you know you're talking about the same people or the same places or the same activities, then this is a way that data can actually be brought together. So you can actually find that information by hitting that node and all of a sudden discovering that there's all this information out about this thing called a Kiwi. Yep. I was going to give you some playtime. I just will say, go onto WorldCat and search out Barry Humphries. Barry Humphries has so many alternative names and personas, it's not funny. But bless them, we can find out all these other personas because they've linked them to this identifier for Barry Humphries. And if you ever want to have a go at this, try and figure out how you would actually describe a group of people or a collection of things and how you would actually try and encode that, these ideas that pop out to you in the way that you would cluster together information.